You walk into class and sit down, and all of a sudden the teacher's starting to talk about something called special right triangles. They just pop these bad boys up on the board with all of these symbols, and you have no idea where they came from, or maybe they went over it really fast and you still don't know where it came from. Or even worse, you're in the next year's class and they're like, oh, you remember your special right triangles? We need that. And you don't remember your special right triangles. So today I'm going to explain what these are, and it's going to help you remember. Hey, I'm Tammy and I do math for coffee. Here we go. This triangle is called the 45-45-90, obviously because it has two 45-degree angles and a 90-degree angle. Now the thing is, if you have two angles that are the same, the opposite sides are also going to be congruent, so we know that that's the case here. This is an isosceles right triangle. If we're given that one of the sides is 3, the other side is also 3. Let's use Pythagorean theorem to find the hypotenuse. We've calculated that c is the square root of 18. We need to break that down. That radical is not simplified. If you need a review on simplifying radicals, check up above. I'll put a link. Let's simplify it right now real quick. All right, so the hypotenuse is 3 times the square root of 2. 3, well, that's a side length, right? Let's look at this again with different numbers and see if that comes up the same way. Let's change the side length to 5 and run through the same thing again with the Pythagorean theorem. We're coming up with the hypotenuse equal to the square root of 50. Let's simplify. 5 square root of 2. That side length is popping up again. Well, in order for it to be a pattern, you have to make sure it happens at least 3 times. And we're doing it again. This time the side length is 10. I'm going to run through all the math real quick. And there it is. The hypotenuse comes out to be 10 times the square root of 2, so there is a pattern here. And that pattern is that in a 45-45-90, the two sides are going to be the same, and the hypotenuse is going to be that side length times the square root of 2. When you see it in a textbook, it's not going to type out the word side. They're going to put a variable there. I'm using the a, just because an x can be kind of confusing. When you get to your problems, the x might be in a different spot. But if we just think side length, side, square root 2. At the end of this video, I am going to give you some hints on how to remember all of this. The next triangle is a little bit different. It's the 30-60-90 triangle. I want to show you a demonstration about something that is always true in a 30-60-90 triangle. In a 30-60-90 triangle, the short side of this triangle will be opposite the 30-degree angle. That makes sense since the 30-degree angle is the smallest one. And the hypotenuse, not the other leg, will be double that short side. Now we use the Pythagorean theorem to find that third side, the other leg. It's the longer leg. We know the side length is 5. We know the hypotenuse is 10. So the Pythagorean theorem sets up like this. In this case, we're not solving for the hypotenuse, we're solving for the other side, so we're going to call that b. And b turns out to be the square root of 75. Let's simplify that radical. There it is, 5 times the square root of 3. Well, that 5 is someplace else in the triangle, right? It's the short side. Let's see if that happens again. This time the short side is 7, and the hypotenuse then would be 14. Let's run through the Pythagorean theorem and the simplification real quick. There it is, 7 times the square root of 3, so the short side times the square root of 3. One more time to lock that into your brain. This one is actually a little bit tricky. In this case, the short side is 1. That means the hypotenuse would be 2 because 1 times 2 is 2. Let's do the Pythagorean theorem. Now we're coming up with b as the square root of 3. That's already simplified. So that other leg is square root of 3, but you don't see the short side. Well, you have to imagine it's there because the short side is 1. So it's really 1 times the square root of 3. When you look at the 30, 60, 90 triangle, the way it sets up is the short side is across from the 30-degree angle. The hypotenuse will be 2 times the short side, and the other leg is going to be the short side times the square root of 3. Something like this is what you will see in a textbook. Most people get this when they learn it, but then they forget it right away. So there's got to be little reminders you can give yourself to be able to remember how these things set up. I'll show you 2 things that work for me. The first is that I know the 45, 45, 90 has 2 congruent sides, and that 2 is the radical, square root 2. The 30, 60, 90 has 3 different sides, and so that number 3 shows up there. For the 30, 60, 90 triangle, it's also the only one that has 3's in it. It has a 30 degrees, it has 60 degrees, which is 2 times 3. The number 3 associates with this triangle, so I remember the square root of 3. And sometime during my teaching career, I had a class come up with names for these things. I mean, it wasn't planned, it was just sort of spontaneous. I thought, well, maybe we should just name them. So they named the first one Bob, B-O-B, because 2 sides are the same, the 2 B's, get it? And they named the other one Liz because all 3 sides are different, L-I-Z, different letters.